3.3, function notation. So, function notation, we're first going to start with what we know, and we know the equation of a line is y equals mx plus b. Now, function notation is very similar, except instead of a y, we're going to use f of x equals mx plus b. Now, what does f of x mean is that we have a function with respect to x. Now, specifically, if we have f of x, which is saying it's a function, it has to be a function. For each input, there has to be exactly one output. It has to pass the vertical line test. Now, same thing as before, your x is still going to be your input, okay? And your x is also occurring right here. And then your f of x, the whole thing, is your output. Now, really, the easiest way to think about this is just that x and y are the same thing. They're kind of interchangeable here. If you put f of x, it means y. If you put y, it means f of x, as long as we're talking about a function. But other than that, it's just the same thing. Reading-wise, it says the notation f of x is read as the value of f at x, or f of x. This is what you're going to hear me say all the time. This is f of x. It does not mean f times x. We're not taking a variable f and multiplying it by x. No, this is standing for, this is a function where I put in an x value and I get out a function value, or I put in an input value and I get out an output value. Example 1. Evaluate each function when x equals -4, when x equals 0, and when x equals 3. So in order to do this, I'm going to make a table. This is an input-output table. It's telling me x is my input, is -4, is 0, and is 3. I grabbed those from right up here. Now, my function is 2 times x minus 5, and that's going to give me my f of x. So instead of putting y up here, which is what we're used to, I'm just going to put f of x, because that's my output. So then we're going to start substituting into our function. So I'm going to have 2 times -4 minus 5. This is going to give me -8 minus 5 is -13. 2 times 0 minus 5. This is 0 minus 5, which is -5. And then we're going to have 2 times 3 minus 5. And then this is 6 minus 5 is 1. So evaluate each function. When x is -4, 0, and 3, we would get the values -13, -5, and 1. Now, another way to write that is I could say f of -4. So I substituted a -4, and I got -13. This was my input. This is my output. This is my domain. This is my range. Okay, if I do that to the next one, I had f of 0. I substituted 0 in for x. Another way to think about that is right there. I substituted 0 in for x equals, and my output was -5. Last but not least, f of 3, and we got 1. These can also be thought of as ordered pairs. This is the ordered pair -4, -13. It's just making dots on a graph. This is the ordered pair 0, -5, and this is the ordered pair 3, 1. I input 3, I output 1. Letter B, g of x equals -x, -1. Or I'm sorry, -x minus 1. So I'm going to do the same thing. I'm going to start with a table. Input, output. This time we're not dealing with f of x, we're dealing with g of x. don't let the variable confuse you. So the last one was f of x. This is g of x. I could also use h of x. We could use p of x. We could use q of x. It's all the same thing. The x values we were dealing with were -4, 0, and 3. And we're going to substitute them into our function. So negative x, so -4 minus 1. Be careful with your negatives here, okay? You have the negative and then you substitute whatever the value is. If I have a negative negative, that's +4 minus 1 is 3. Negative, substitute 0 minus 1 is -1. Negative, substitute 3 minus 1 is -4. Now again, these can be written in function notation as g of -4 equals 3, g of 0 equals -1, and g of 3 equals -4. Or we could write them as ordered pairs and just pull them right off. -4, 3, 0, -1, 3, -4.